Most of you probably know Ted, but I'll give you his bio here. Ted Hopwood is a program manager for bridge preservation at the Kentucky Transportation Center, a research center attached to the College of Engineering at the University of Kentucky. He obtained his BS degree in mechanical engineering at the University of Kentucky in 1969 and his MS degree in metallurgy at the University of Kentucky in 1975. He previously held positions in private industry and with the Kentucky Transportation Cabinet. He has been employed at the Transportation Center since 1981. Mr. Hopwood has worked on a wide variety of transportation research projects, subjects including facilities management, non-destructive testing, maintenance practices, project development, coatings development and testing, corrosion analysis and prevention, and environmental issues. So Ted, please come on up.
Good morning, everybody. Today I'm going to give a report on the work of the Bridge Expansion Joint Committee. This committee was formed to develop a bridge expansion joint matrix and document prevailing practices using national bridge elements as a common platform for communication. The committee is in the West Bridge Preservation Partnership, consists of officials from 5 state DOTs, and then there are representatives from 3 joint manufacturers, a consultant, and myself. The initial work on the bridge expansion joint matrix focused on 3 different joint types: strip seals, element 300, pourable joint seals, element 301, and compression seals, element 302. Part of the work consisted of the preparation and submittal of a national survey to state highway agencies, and based on the responses, the documentation of what we term prevailing practices, or the most common responses. Now, the matrix, as it's intended to be developed, will be classified by joint type and with product information for the specific joint categories from each manufacturer. It'll contain installation practices, practices to avoid, design practices, and estimates of life expectancy of the joints. To conduct the survey, an internet survey tool was used. SurveyMonkey is pretty common, and the committee hoped to get perspectives on joints from both the design and maintenance sectors of the state highway agencies. And the interesting thing about this is that the survey questions were prepared primarily by state highway agencies rather than university professors or researchers. And the focus areas in the survey included joint usage and limitations, life expectancy, constructability, maintenance, design and configurations, field conditions and installation, movement, and agency informational needs. Once the survey was prepared, the West Bridge Preservation Partnership sent it to state highway agencies in all 4 of the bridge preservation partnerships. And this survey was submitted, I think, in about January of last year, and the final responses were obtained in March of 2014. And the responses represented 25 state highway agencies. There were a total of about 57 participants with some secondary contacts, and The committee received 46 completed surveys. The bulk of these, in terms of the positions of the respondents, represented maintenance and design. There were 40 respondents that commented on strip seals. 90% of those said their agency used strip seals, and 10% said they didn't. The reasons for usage included favorable size and movements, longevity, and a past history of success. There were some limitations to the use of strip seals that were noted by the respondents. About half of them said that they shouldn't be used in areas where there was a lot of snow plowing, where bridges had large skews, or there were small openings and movements, and that accounted for about 3/4 of the reasons for not using the joints. The maintenance issues included debris impaction, seal damage, joint leakage, and for all of these joints, the respondents, about 3/4 of the respondents said that they didn't regularly clean or reseal joints. In terms of variation in responses, there were variable criteria for use based on bridge skews. There was a variety of anchorage types that were used. In some cases there was coatings on the hardware, in some cases there wasn't. And there was variable practices in terms of determining joint movements. The prevailing practices for constructability and field condition were the use of formed blockouts, the allowance of rail splices, no splicing of the gland, and the use of state inspectors during installation of the joints. And about half of the reasons for not using the joints was related to the difficulty to maintain them. About 2/3 of the states that responded used pourable joint seals. Again, we had about the same number of 39 respondents in this case. The reasons for using these included low installation cost, constructability, low maintenance cost, and ease of maintenance. There were some areas where the respondents noted that pourable joints shouldn't be used. One was where there were large joint openings or high joint movement, and those two counted for about 3/4 of the reasons for not using pourable joint seals. In terms of maintenance issues, problems, the major problem was seal adhesion, followed by joint leakage, and then debris impaction. There was some lack of consistency in state practices related to joint preparation and cleaning of the substrate, allowable skews, gap openings, movement ratings, and the determination of movements. The prevailing practices related to limit the skews to 0 to 10 degrees. That was 58%. Saw cutting of the joint was not required by about 2/3 of the states. And the reason that the joints weren't used, the prevailing reason was seal adhesion. For compression seals, this is interesting. About 55% of the respondents said that they used compression seals, and about 45% didn't, which is a pretty high number of not using it anymore. The reasons for using the joints included favorable size or joint movements, constructability, low maintenance cost, and low installation costs. There was several areas that were where the use of compression seals was discouraged. The primary one was large skews or movement, extreme temperature ranges, and interestingly enough, rehabilitation projects. And I imagine that means that when they rehabilitated decks, they either took out the joint or they used a different type of joint like a strip seal. Primary maintenance issues related to joint leakage, seal adhesion, seal damage, and debris impaction. In terms of lack of consistency in responses, the respondents used these on a variety of substrates. There was difference in the cleaning that was specified, the proper depth of the seals, and the method used to determine joint movements. Prevailing practices, again, the skews were limited to 0 to 10 degrees by most states. A little bit over half allowed field splicing of the seals, and of those, and most of those required the splicing to occur at the lane lines. Again, 2/3 of the respondents said they wouldn't require saw cutting of the joint opening. And in this case, there were some product requirements. About 2/3 of the respondents said they wanted to have certificates of compliance, and about half used state testing of the joint seals. If we look at life expectancy of the joints based on the responses, it's pretty obvious that strip seals have the highest service lives. Over half exceeded 15 years. That seal durability was followed by compression seals, with about half of the compression seals or respondents on compression seals saying that they had service lives of 10 to 15 years, and the poured seals generally had lower service lives, with the majority reporting, or about nearly half of the respondents reporting service lives 0 to 5 years. So moving forward, our center is going to assist the committee, take the data, and basically organize the matrix. And the second step is the committee's looking at focusing on a new survey addressing assembly joints with seals, the type 303. And the committee is also going to investigate the feasibility of correlating their data with findings of other partnerships. And with that, I'll be glad to answer any questions to the best of my ability.
All right. Thank you, Ted.